After the product rule, it seems natural that the next rule that we would learn is the quotient rule. And like the product rule, you can't just take the derivative of your numerator and divide it by the derivative of your denominator. We get a very nice, complicated rule. And the hard part is you do have to have all these rules memorized. So, quotient rule. We have originally one function in our numerator and one function in our denominator. When this is the case, we keep the one that's in your denominator the same, multiplied by the derivative of the one in your numerator. So I like to say keep the second one the same, multiply by the derivative of the first one, minus, and now we keep the first one the same, and multiply by the derivative of the second one. So at the start, the quotient rule is almost the same idea as your product rule, except one has subtract, one has add. But because one has subtract, the order matters now with the subtracting one. You have to, because one thing is negative, one thing is positive, you have to keep your denominator the same first. So keep the bottom the same. And then after you've done the top part, you keep the bottom the same again and square it. So we can look at the same thing in Leibniz notation, color code things the same. We keep the bottom function the same, then multiply by the derivative of the first function, then keep your first function the same, multiply by the derivative of your second function, and then you keep your second function the same and square it on the bottom. So what does this look like in some questions? Right? What is the derivative of x cubed over 3x minus 7? Simplify your final answer. So our derivative will be keep the bottom the same. Multiply by the derivative of the top. Subtract. Keep the top the same. Multiply by the derivative of the bottom all over the bottom squared. How do we simplify this? Because it says simplify in your final answer. Well, we'll multiply in our numerator. So dy dx equals, this will become 9x cubed minus 21x squared minus 3x cubed over 3x minus 7 squared. Generally, we wouldn't multiply out our denominator here because it has been factored. And factoring something makes it closer to being simplified than having it not factored. What I'm going to do in my numerator is I'm going to combine my like terms, and then I'm going to check, is it factorable? dy dx, after I combine my like terms, I get 6x cubed minus 21x squared over 3x minus 7 all squared. And I'm going to factor my numerator here. I notice there's a common factor. There's a 3 in common and an x squared in common. And the reason I factor my numerator is to see if a factor that I'm left with would simplify with a factor on the bottom. But after taking out the 3x squared, I'm left with 2x minus 7, which is close, but not equal to 3x minus 7. And so I would be able to say at this point, it is simplified because nothing cancels out further. So again, for all the questions that you get, what I want you to start looking at is what does the answer key look like? That's the simplified form. can you manipulate your equation to match their equation in the answer key? So do you notice how the power rule keeps coming back even when we're doing quotient rule and product rule and sum and difference rule? It's all coming back to that basic first rule that we learned where the exponent comes in front and we subtract 1 from the exponent. Now that's just built in to a quotient rule or a product rule. So here we have a quotient again. We're going to use our quotient rule, which says keep the bottom the same, 3x minus 7x to the 4. Multiply by the derivative of the numerator. So that'll be 2x plus 5 minus, keep the first term the same, 5x plus 3, multiply by the derivative of the bottom. Oh my goodness, I'm going to have to move things over. There we go. You can do that on your page too. And multiplied by the derivative of the bottom, which will be 3 minus 28x cubed, all over the bottom squared. This one didn't say to simplify, so we're going to just leave it. So can you see how we kept the bottom the same, multiplied by the derivative of the top, then kept the top the same, multiplied by the derivative of the bottom, over the bottom squared. Okay. Find the gradient of the tangent to y equals x cubed over x squared plus 1 at x equals negative 1, and find the equation of the tangent line at x equals negative 1. So we haven't seen questions like this for a little while, but, okay, find an equation of a line anytime you want to find an equation of a line, you need a point and the slope. It doesn't look like they told us any of this in this question yet. So we have to say, how do we find the slope and how do we find a point? Once we have both of those things, finding the equation of a line is going back to grade 10 math, and that's actually not too bad. Okay, well, gradient is another word for slope. So it wants us to first find the slope of the tangent to that equation at x equals negative 1. And this is where we really have to understand, what does a derivative mean? When we find a derivative, so for example here, I can use my quotient rule and find the derivative, keep the bottom the same, derivative of the top, minus keep the top the same, derivative of the bottom, over the bottom squared. There's my derivative. But what does my derivative mean? My derivative is an equation that finds the slope of all the tangents at all the points. At x equals minus 1, my derivative would be 1 plus 1 times 3 times 1 minus negative 1 cubed would be negative 1. 2 times negative 1 would be negative 2, all over one plus 1 squared. So if I multiply this out, I'm going to get 6 minus 2 over 2 squared is 4. And if I write it out in words what this means, at x equals -1, the slope of the tangent to that curve is equal to 1. Now, if I scroll back up, the two things I need are a point and the slope. I now know my slope is equal to 1. I need a point. Well, and I'll just do it off to the side right here. If you know the x value at x equals -1, could you find the y value on your actual graph? Yes. We've got the equation. We know that y is equal to x cubed over x squared plus 1. That will tell me my y value has to be -1/2. And so now I also know my point. My point is at -1, -1/2. We can now find the equation of our tangent line. We know that our point was -1, -1/2. And we know that our slope was 1. If you wanted to use y equals mx plus b, you know what your slope is, it's 1. You know your point, you can plug in -1 for x and -1/2 for y. And the only thing you don't know is b. Add 1 to both sides. Solve for b. And our equation of our tangent line, y equals mx plus b, we now know that m is 1, and we found out that our y-intercept is 1/2. So we can write our equation of our tangent line. This is typical of what you're sort of going to do in your textbook. So when you do a question, you're going to look at your answer and you're going to say, ooh, the answer looks like x squared plus 4x minus 7 over x plus 2 squared. Can I make my derivative look like that? So we'd start off noticing I have a quotient, so I'm going to do my quotient rule, keep the bottom the same, multiply by the derivative of the top, minus keep the top the same, multiply by the derivative of the bottom over the bottom squared. So initially, I'm looking at what I ended up with just using the quotient rule, and I'm excited because my bottom, or my denominator, is already the same as what the answer key apparently has. I have an x plus 2 squared in my answer. I have an x plus 2 squared in my denominator in what I have. So it looks like if I just simplify my numerator, it should work. Let's see if it does. If I multiply this out, I'm going to get 2x squared plus x minus 6 minus, if I distribute the minus, minus x squared plus 3x minus 1. All over x plus 2 squared combine my like terms. 2x squared minus x squared is x squared. X plus 3x is plus 4x minus 7. I sure hope that's what we want it to show. Is it? Yes. And then part 2 of this question Okay? And so whenever you're writing an exam or a quiz, I always suggest rereading the question once you think you're done, because that's when I often found I wasn't done. Because you feel like, yes, I got it. You're just all excited, just want to move on. We go back, we read this question. Hence, find all the values of x where this, where of x, where, oh, nice. Just get rid of this. I should have reread it after I wrote it, so it would have made sense. Hence, find all the values of x where dy dx is undefined. So first of all, we have to revisit a definition that we've seen before, but maybe have forgotten. What does it mean when something is undefined? It means that it's not possible. Are there any values you're not allowed to use? Well, in mathematics, we're not allowed to do a couple of things, right? dy dx is undefined when, well, what are the things we're not allowed to do in mathematics? Okay, the list gets bigger the more math you learn, right? In grade 1, there's nothing you're not allowed to do, because all you do is add and subtract. And you can add and subtract any numbers. In fact, your numbers are probably just positive whole numbers at that time, right? It's not until you get to maybe grade 4 or 5 that you learn the first thing you're not allowed to do, because you start learning dividing. And one of the things you're not allowed to do is divide by 0. So in this case, it's undefined when x equals -2. Sometimes we say, or we show that by saying, so x can't equal -2. And then a little bit later, you find out you can't take square roots of negative numbers, right? And then in grade 12, we get some other ones. You can't take logarithms of negative numbers or logarithms of 0. How strong are you with that one? You can't do the inverse sine or inverse cos of numbers bigger than 1. Can't do cos inverse of 7. Try it on your calculator. It gives you an error. So we keep adding to the list of things you're not allowed to do the more functions that we learn. So we're going to take the rest of class to work on the product rule and the quotient rule. Quotient rule, I'd say, is probably the best one for practicing your algebra skills in seeing if you can make them match.